Hello and welcome. In this video, I'm going to take a few moments to explain how to use Ohm's law to relate resistance and current in a circuit. Up till now, in our COVID-19 shelter-in-place distance learning at Pebble Hills High School, we have had to do very little physics calculations. Perhaps you thought you would have a break forever from those. Alas, the calculations have come, and because of that, I really want to make sure that you know how to do it. So that this video isn't too long, let's just get right to it. Ohm's law. In your reading, you should have discovered that current is the flow of electric charges in a circuit. Current is measured in the unit amperes. Often we just call them amps. And we have the symbol for current in our formulas as a capital letter I. Don't let that confuse you. You might be tempted to put a C or something, but no, it is the capital letter I. So when you see I, even though current doesn't start with an I, that's our symbol. Okay? The speed of the current in a circuit can be affected by several different things. For example, depending on what your wires are made of, a lot of times our wires in our homes are made of copper because that allows for really less resistance of flow, so our current is as fast as we can optimize without getting dangerous. The length of the wire, the thickness of the wire, that will affect the current. The voltage will also affect the speed of the current. If the voltage is increased, then the current will also increase. As you learned in the last section of reading, the way that we measure current is with an ammeter. So any of you who've worked on a car, a lot of times you want to see if there is current flowing through some of your circuits, you might pull out an ammeter. Okay, I know my dad always did. I grew up, he was a mechanic, and he always had an ohm meter and an ammeter. Okay, with current, there's two different types. There can be direct current. We say DC, that means direct current. It's always flowing in the same direction. That would be like with batteries. So last week on our PhET simulation, you were using direct current. Okay? You could use alternating current. That would be when the electrons would reverse direction of flow. Sometimes they go this way, sometimes that way. It can be up to 60 times per second. I mean, that is super fast redirection of flow. And that's the kind of current that we have in our homes. Okay. The other quantity that we want to take into account when using Ohm's law is voltage. Voltage is the push that makes electrons flow. They have the potential to flow, and they won't on their own. So you have a battery, and it's a 9-volt battery. There's nothing flowing unless you complete that circuit and make a path for them to flow. Okay. That has a potential difference on one end of the battery to the other end. You notice there's a positive end and a negative end. Okay, so that's why it's called potential difference. Also voltage. We measure it in volts. The symbol in the equation is also a V. So the unit is a V and the symbol in the equation is a V. So that should be easy to keep track of. We measure potential difference with a voltmeter. And you should have used one of those as well in your PhET simulation. Okay, now with resistance. Resistance is any opposition to the flow of electrons. Okay, you can have a lot of resistance if you put in a poor conductor. So for example, let's say you have a circuit, and all of a sudden, in place of a wire, between two wires, you put a piece of wood. Do you think the electricity will flow very well? Probably not. There's a lot of resistance in there. Okay, and if you had really thin wires, there would be resistance to the flow. If they're really long, they have a long way to go. That's more resistance as well. Any opposition to the flow of those electrons. Now we measure resistance in the unit ohm. We're going to use the Greek letter omega, the last letter of the Greek alphabet. It looks like a little horseshoe. The symbol for resistance in Ohm's law equation, we're going to use R. Okay? All right, so let's just look at Ohm's law all together. We see voltage is equal to current times resistance. Remember, voltage is the letter V, current we represent with an I, resistance with an R. Do not confuse the symbol in the equation with the symbol for the unit. The unit is how we measure. We measure voltage with volts. We measure current with amperes, amps. We measure resistance with ohms. Okay, and let's wrap this video up with 3 quick examples. This one, example 1, calculate the voltage. I'm looking for V. Okay, so I'm going to circle the one I'm looking for, across a 3 ohm resistor. I remember that the unit ohm is for resistance, so I'm going to put that in place of the R times if a 0.5 amp current is flowing through it. So that must be in place of I. I is current. So I'm going to put 0.5 amps. Okay, and I'm looking for V. So 0.5 is like 1/2. 1/2 of 3. What if I had $3? What's half of $3? $1.50. So it's 1.5. And what is the unit for volts? Voltage? Volts. I gave my answer away. Okay, let's look at example 2. A radio with a resistance of 240 ohms. So that's going to be my R, my resistance. I'm going to put 240 ohms. Is plugged into a 120 volt outlet. So 120 volts, that's my voltage. So I'm going to put it here. Sorry for the messy handwriting. I'm learning how to do this digitally. It says, what is the current flowing? So I'm looking for the letter I. How can I get I by itself? I'm going to divide both sides by the 240. 120 divided by 240, 240 divided by 240, that's 1. So I is left by itself. What is 120 divided by 240? That's, they look like they're multiples of each other. It looks like it's going to be 1/2. And the unit for current is amps. So it's half of an amp. Okay? And then finally, my third example. What is the resistance when 6 amps, oh look, they didn't give me the formula. I have to remember it or look it up. Voltage equals current times resistance. Okay, the resistance is what I'm looking for, so I'm looking for R. When 6 amps, do you remember what amps measures? I'm looking for R, so I'm going to leave it R. Amps measures current. 6 amps times whatever resistance. It's flowing through a circuit with 120 volts. Okay, so now I need to solve for R. How can I get R by itself? Divide both sides by the 6 amps. Here they're going to cancel. 120 divided by 6. Well, I know 12 divided by 6 is 2, and then so that's basically going to be 20. And the unit for resistance? Ohms. So there's my final answer. As always, if you're having trouble with any of the calculations or any of the assignments, please message your teacher on Remind or send an email. We are here to help. All right, happy learning.